Welcome back to 6-2. On the last slide, you should have written all of this down. If you did not, make sure to go back and get that written down so you can always refer back to it. These are things that are going to help us to know about trapezoids and kites. All right, on the inside, I changed up that first square. We actually will not do that first square until 9-1 at the end of this unit. So if you want to glue a piece of paper over it and put this there instead, you can. If you don't glue these into a notebook and you just keep them in like a binder, you're welcome to use that blank space right there in the foldable as well. So your choice. So when we're talking about trapezoids, there are many different types, but the ones with the most, I don't want to say important, but that have the most unique characteristics are ones that are isosceles trapezoids. So isosceles trapezoids mean that this angle and this angle are the same, and then these angles are the same. So in this first example here, it becomes very easy to know that, oh, that one's 135. And then the angles here are like opposite, same side interior. Sorry, same side interior here. So when they're same side interior, that means they add to 180. So 135 plus what is 180? You can also think about that as just subtraction. So that is 45. So I know that these little angles here must be 45 degrees so that they add up to 180. Also with isosceles triangles, it means that these are parallel. That's why I could use that word as same side interior to make that true. So finding the angles is not too difficult. You just got to remember the adding up to 180. Something else special about isosceles trapezoids is that their diagonals are equal. So if you look here, MP is equal to NQ. I'm going to undo those because those lines are ugly, but those two diagonals are equal to each other. That also means that the little pieces are equal to each other and the big pieces are equal to each other. And I said that backwards, but you get the idea. So in this example, we have that MR is 3x plus 5. Notice that stops right here. RP is 8. And then the entire thing of NQ is 5x plus 1. So remember, the entire thing of NQ, which is 5x plus 1, is equal to the entire piece of MP. So maybe we write that above. I'm actually going to write that above that. So NQ is equal to MP. So that means that 5x plus 1 is equal to 3x plus 5 plus 8. We got to also have that plus 8 part there. So then we get 5x plus 1 is equal to 3x plus 13. Okay. Subtract my 3x to get 2x plus 1 equals 13. Subtract 1. 2x equals 12. Divide by 2. So x must equal 6. We're almost there, but we still have not actually found the length of NQ. So in order to find that length, I need to plug that back into 5x plus 1, but instead of x, I'm going to put 6. So 30 plus 1 is 31. So the length of the diagonal is 31. I should also get that the length of the other diagonal is 31 because remember, they are equal. So 3 times 6 is 18 plus 13 is 31. All right, last cool property of a trapezoid is the mid segment here. Okay, so with a mid segment, this is equal to this. Okay, so that helps. But then what's also really cool is that this middle number is the average. So remember, average is found by adding the two numbers, so the short side and the long side, and dividing by how many of those numbers there are. So in this case, there's just two numbers. So 54 divided by 2 is 27. So I know that Z must equal 27. Okay. If you had to do the harder way, what if I had the two outsides added together, still divided by 2, but this time I know it has to equal 4. That makes it just slightly harder, but just by one step. First thing we gotta do is multiply both sides by 2 to get rid of that fraction bar there. And the last thing we want to do is subtract 5.6, so I get 2.4. All right, so that's everything you need to know about trapezoids.